Good afternoon, gentlemen. I hope you are all well. Welcome to your eighth week of physics. We'll be looking at P3.4, energy and the environment. Really, it's just carrying on with everything that we've been looking at in terms of renewable and non-renewable sources of energy. So hopefully the whole lesson really should take you sort of between 40 to 50 minutes, maybe even less for some of you, especially if you're quite familiar with the areas that we're going to be talking about today. And I suspect that actually a lot of it has already been covered in some of the previous lessons that we had. So today we're going to be looking at primarily fossil fuels and how they compare to nuclear power as a source of energy. I've given you the book references there, obviously slightly different if you're using the triple or the combined book. And I would advise when doing the worksheet, which consists of 3 questions that you will do at the end of this presentation, maybe have that open as well, just for some additional guidance if you need it. Okay, so by the end of the week, by the end of this lesson, you will be able to explain the advantages and disadvantages of both fossil fuels and nuclear power stations or the use of nuclear energy, and be able to compare and contrast the two of them, and explain ways of reducing the negative effects of both of these sources of energy in terms of the environment. So obviously fossil fuels have their disadvantages in regards to the environment, and so does nuclear power, and we're going to be looking at what people do in industry in order to reduce these disadvantages to the environment. Okay. Now, in terms of energy demands, and this I think sets the context for why we use certain sources of energy more than others. Obviously, if we think of our day-to-day lives in terms of work and at home, let me just move myself out the way there so that you can see the list. You can see that, and this is in the context of um the human population as a whole, as opposed to just the UK. You can see and clearly the two leading um, sections of the. Oh, let me just stick this on. Right, the two leading sections that contribute to demand of sources of energy is obviously oil and coal. And so you have to bear in mind that whilst the more economically developed countries are surging ahead in terms of their use of renewable sources of energy, there is a significant majority in terms of energy demands of the world that still tend to use the more traditional sources of energy, as we're going to be looking at, as we're going to be discovering, which is fossil fuels. So and actually, we'll come back to this later on, where we compare the UK's breakdown. And I suppose it's useful to actually read around this topic because, as I mentioned in I think it was 3.2, that this topic does lend itself to case studies in the exam and 6 marker questions. So it's definitely useful to have understanding of the wider context. You're not expected to know these statistics for the exam. You might be you might come across a question where they give you figures within a question, and you basically have to analyze that, but you're certainly not expected to know this stuff. But it's useful nonetheless to just discuss and explore the topic itself. um, I mean, as it basically says there, the majority of our energy demand is coming from fossil fuels, um, quite simply because it's the most accessible. So when we look at oil and coal, these two sources are the most accessible worldwide, and anything which is easily accessed means it's cheaper to mine. And if it's cheaper to mine, obviously energy companies are going to be looking to make a quick buck, lack of a better term, and try to make as much money in as short time as possible. So rather than perhaps spending 5, 10 years developing technologies to harvest efficiently the sun and the wind, why would they do that when they can perhaps make 3 times more money in space of a fraction of the time? And this is effectively what tends to happen. It's the same reason why electric cars, for example, are so much more expensive, because there isn't yet that investment on a wide scale as there is, of course, with investing in fossil fuel harvesting technology. So it says at the very end here, it says we are developing and making greater use of renewable sources. It definitely is the case for, as I said, economically more advanced countries, although even within that, there are certain sort of contradictions, if you like, where the US, as very famously, when Donald Trump came to power, one of the first things he did was sign them out of various environmental accords that the country had signed up to, pledging to reduce CO2 emissions, pledging to reduce the reliance on fossil fuels. So even actually within the context of the more economically secure countries, some of them are actually the worst in terms of environmental impact and how they use energy. So again, we'll touch on that later on. But this gives you a very clear breakdown of what's happening around the world. So what are fossil fuels? Well, again, I think all of you have covered this in chemistry when you looked at hydrocarbons. And fossil fuels, of course, as the pictures there suggest, is coal, gas, and oil. And without going into too much detail on how these were made, again, this is something that you discussed in chemistry, but effectively this is organic matter as a result of millions of years with heat and compression. Organic matter gets buried, and as a chemical transition changes into this viscous thick liquid, which we call crude oil. Coal and gas are obviously derivatives of the same process. How does a fossil fuel power plant work? Well, again, this is something that you probably covered in Key Stage 3, but we will go through that in the next slide just to jog your memory. And we're going to be looking at what the advantages and disadvantages are. Okay, so here is a simple setup of a traditional power station. Effectively, what happens first is the fossil fuel, which in this case is coal, and certainly here in the UK, in the 1970s and early 1980s, over 80% of the electricity or current, the electricity generated in power stations came from coal. And in the north, we have coal mining communities, and many of these quarries have since coal mines have since closed. Obviously, as our reliance has moved away from coal, but all around the world, traditional fossil fuel power stations are a common thing. So the coal is taken into a furnace, it's burnt, and the heat generated from that combustion heats up water. The water then produces steam. The steam actually powers turbines, and the turbines, as you will later learn next year, hopefully, when we look at electromagnets, the turbines spin around an electromagnet, and it's within a generator, and it's the generator that's actually creating this current, yeah, also known as electricity. And the current that's then produced goes through a series of transformers, which basically changes the voltage in the current to make it suitable to travel across the national grid and then distributed from there to our homes. So that's something that we'll look at in greater detail later on. But for now, it's important to just understand this basic process of how electricity is generated from within a traditional fossil fuel power plant. Okay, and you are expected to know, according to your spec, the main different, the fact that the coal comes in, it's burnt in a furnace or a boiler, that then heats up water, which produces steam, which turns a turbine within a generator, and then that spins the generator, and then that generates the electricity. So please be very sure about being able to write that in the correct order. Um, Looking at the advantages, obviously the advantages of fossil fuels is they're very reliable. Petroleum companies know uh, to a high degree of accuracy how much oil or coal or gas even is contained within a particular reservoir under the Earth's surface. We have various X-raying techniques and geographical or geological techniques that allow us to be able to look in and see and calculate and estimate, as I said, to a high degree of accuracy, just how much there is. And we know, of course, based on our current usages, and again, accurate predictions, roughly how long each fossil fuel source would last. And so collectively, we anticipate fossil fuels ranging, depending on which one, coal, oil, or gas, going anywhere from between 80 years to 250 years in terms of use. We'll look at that in a bit more detail, but as I said, it's reliable. It's reliable in the sense that also we know from how much mass of a fossil fuel, we know exactly how much energy is actually released as a result of that combustion reaction. So in that regard, we then can also work out just how much electricity is going to be generated. So it's very, very reliable in many different ways. Short startup time. What that means is that the technology to harvest this fuel source has been around for over 100 years. It's proven, it's tested, and it's very much established all around the world. Good to meet basic demand. Obviously, this goes back to the idea of it being very accessible, and even poorer countries with limited technology can certainly capitalize on this fuel source. And in terms of disadvantages, this is where, as I said, a lot of the 6 mark questions will pop up. So the first two is the emissions of CO2 and SO2. Now, carbon dioxide leads to us um, talking about global warming. It's a greenhouse gas, so effectively it acts as a heat sink for the atmosphere, for the environment. So the more CO2 there is in the environment, global warming suggests that the average temperatures begin to rise, and that has all sorts of different effects on the environment, such as the melting of the ice caps, which increases the sea levels, but it also has a detrimental effect on certain habitats and the survival of certain species of animals, and no doubt this will affect us as well. And really, in the last 10 years, there's been so much more awareness about this issue, partly because we've noticed a change in trends of weather patterns, whether that be in the winter or in the summer. So more extreme winters, or actually in our case, it's probably been more milder winters and hotter summers here in the UK. So that's CO2. Now, with the sulfur dioxides and the nitrogen oxides, which are produced by this combustion and the emissions of using fossil fuels, then that actually goes towards causing acid rain, which has a massive effect on building material. Obviously, if much of our building material contains alkali compounds or basic compounds such as marble, like calcium carbonate, then over time the acid rain is going to erode it. It also has a massive effect on agriculture. If the pH of soil changes too drastically, then this is going to affect the harvest, and it's going to affect certain growth of crops. As I've recently discovered, and I had absolutely genuinely no idea, to the fact that certain plants will only grow in certain soils. And my wife has had me gardening during this lockdown, and I've realized that my fig plant It's completely in the wrong type of soil, which is why it's absolutely dead now. It's a sad state of affairs. It looks like the driest. It's just basically just a twig now. It was like this luscious tree, and I managed to kill it in about 3 weeks, despite the fact that we've had glorious sunshine and amazing weather. Anyway, I've gone off topic as I usually do, but let's get back to topic. So, acid rain is pretty bad for the environment in terms of it increasing the pH of the soil. And actually, the nitrogen oxides that are released have contributed massively, and this has been in the news, to respiratory issues and general reduction of air quality. So diesel cars are uh, uh, the main area where nitrogen oxides are being released as a result of combustion of diesel. So obviously I've been talking about fossil fuels and I've been speaking about coal. That's in the context of a power station and what that uses to burn. But if you think about our vehicles, all our vehicles, and as you know from chemistry, from looking at fractional distillation, we take crude oil, we distill that in a fractional distillation column, and then we have all of these different fractions. These are fossil fuels. These are examples of fossil fuels, whether we're talking about kerosene that used in planes, diesel in cars and trucks and what have you, or petrol, whether that be leaded or unleaded. They all produce these sulfur dioxides and nitrogen oxides, and obviously your carbon dioxide as well. Okay. Um, Another disadvantage: fossil fuels will run out. This is obviously the main issue, is that they are finite. And whilst in the last, uh, I think the last major discovery of an oil reservoir was, if I recall, 5 years ago in Venezuela. They found a humongous oil reservoir, which was believed to have increased the world's reliance on oil by about 120 years, which is a phenomenal figure. But there is a caveat. There are these reservoirs of crude oil that they discover are actually graded in terms of accessibility and the quality of the crude oil itself. So although it's a huge reservoir, it's deemed to be quite inaccessible because of its depth and just because of the geology of the area in which it resides, and the quality, the purity of the crude oil as well was deemed to be not that great. So although it's huge and it can sustain the production at the current rates, it's not a main priority. I'm sure at some point it will be mined and it will be harvested, because it's money for these huge oil and gas companies. They, I'm sure, will not miss on an opportunity to make their billions. So as fossil fuels run out, they become more expensive. Fuel costs go up. So actually, at this moment in time, petrol is at its all-time low. I say all-time, but I think certainly in the last sort of 6 years, I think 2012 or 13. I was listening to the news the other day. Has it been this low since then? But we're paying around sort of £1, £1.10 per litre. Well, I remember when I was in primary school, my dad used to fill up at 56 pence. So it's doubled in price in terms of how much we pay. And even countries in the Middle East that have traditionally paid anywhere between 5 to 10p a litre. So it's actually cheaper to buy petrol than it is to buy bottled water there. Even that is now extortionately expensive. Like in Saudi, they pay around 50p a litre. So, I mean, imagine that, 50p. I mean, you can't even buy you could probably buy a cheap drink, something sugary and fizzy from the newsagent on the roundabout. But I mean, that's 50p is incredible, incredible. But even then, for them, the price of petrol has increased maybe three or fourfold. So it's definitely going up for everyone, and it will only continue to be more and more expensive. So these are the main advantages, disadvantages, and advantages for you guys. You need to be clear about the effects of CO2 and SO2. And this is what your specification actually talks about. And of course, I've just explained them here. Okay, so be aware of that. Okay, let's move on. Um, yeah, so uh, these figures are constantly changing in terms of roughly how much estimated time we left. So there's slight caveats I need to give to these figures. So it says that crude oil has 50 years left. That is based on um, the current discovered and harvested reservoirs. So there are other discovered reservoirs that have not yet been tapped, and as a result, therefore, they're not included in this 50 years. If they were to be included, like there are a couple of oil fields again around sort of the Middle East region and off into the Indian Ocean and the Arabian Sea that haven't yet been tapped. There's that massive one in Venezuela. There's another huge one to the northeast coast of Canada. If we combine all of those, and if they actually get tapped, then this particular figure here is estimated to be beyond 200 years. So yes, it's finite, and yes, it's important that we begin to invest in alternative sources of energy, as we're going to be looking at. It's perhaps not as immediate as I think some people think it might be. But even 200 years, you're talking about 3 to 4 generations, which is, or even, which is not a massive amount in the context of human history. That's very quick indeed. Natural gas. Again, there's been much in the news about fracking. So fracking is the process of using high pressured water or even gas, in fact, such as CO2, to break up pockets of gas that are trapped within rock structures under the surface of the earth. This has caused uh, protests, certainly here in the UK, about fracking, and many projects have been suspended since the protests because it's been found that fracking can actually affect the stability of the ground and the vicinity in which the fracking is taking place. And I think in certain regions of the UK, when companies were fracking, residents experienced sort of mini tremors, which are perhaps not strong enough to be classified as earthquakes, but there's certainly some sort of geological disturbance there. And coal, as you can see, coal, which is by far the most abundant of the fossil fuels, on our current usage, on our current consumption, it's estimated to last another 250 odd years. Okay, now these are all estimates, and they will go up and down depending on many factors, such as consumption and such as discovery of new sources and new fields. We'll talk about what can actually what we're doing in order to um, mitigate some of these disadvantages to the environment. But also, we've just been discussing in the last couple of lessons what the alternative is of using these fossil fuels. In this lesson, in particular, we're going to be looking at this idea of actually. Just before I do that, I wanted to just share with you this link. Um, in terms of the usage, if you recall the very first slide that I showed you, over 70% of reliance around the world was on fossil fuels. But actually, in the UK, it's a very different story. Now, this is an article from January, and it says that renewables beat fossil fuels on 137 days in greenest year for the UK. So what that basically means is that in 2019, for 137 days, we produced the majority of our energy from renewable sources as opposed to the fossil fuels, the fossil fuel power plants. Now, why was it only 137 days? Well, again, this is one of the disadvantages of these renewable sources of energy, because they are, in this country, mostly to do with wind and hydro. And there are some solar energy farms as well. But one of the things we looked at in previous lessons is that they're not terribly reliable. And we rely on the fact that it has to be windy in order to generate any power on a wind farm. It has to be sunny in order for the solar panels to generate any electricity as well. And obviously, that comes and goes. But for 137 days in 2019, um, it was the case that we generated the majority. Now, the majority, when you look into it, actually range from between 51% to around 63% of the energy for that particular day. And it's interesting if you compare to previous years. So here's 2018, this is 2017, 16, 15. Now, this doesn't mean that the weather has changed, that it's become more sunny and more windy. No, of course, it simply means that we have invested as a country more into building more wind farms, more solar powers. So the link to this particular article is at the bottom of the slide. I definitely, it's not a very long article. It really is. That's it. So I recommend you guys just reading that. But here's another interesting one. 75% of UK's electricity came from coal in 1990. Last year, it had fallen to just 2.1%, which is really a massive, massive transition in just a few decades. And you can see here the breakdown of the different areas that we are harvesting our energy. Okay, so let's go back to our PowerPoint. Right. Okay, so with nuclear power, now this is quite again an interesting one. Nuclear power stations. In a nutshell, how they work is we use some sort of radioactive material, and it says here usually uranium or plutonium, and this radioactive material, and again we'll be looking at this in more detail, but radioactive material has a tendency to break down because it is unstable. As it breaks down, this releases energy. Now, this emission of energy we call radioactivity. And the thing with these radioactive isotopes is that when one breaks down and releases this energy, that energy then goes off to um, uh, start the same chain reaction and causes more radioactive material to break down. So this is effectively what we call radioactive decay. Now, this process of radioactive decay occurs within a nuclear power plant, but of course it's controlled within a nuclear power plant for two reasons. One, because it's safe to do that, and secondly, so that we can control just how much energy we're actually generating. So it says the energy from nuclear radioactive material in the core releases a lot of heat energy. It's that heat energy which then goes to heat the water, which produces steam. The steam turns turbine. The turbine turns the drive shaft within the generator. The generator then produces an electrical current, and that current travels through the national grid and then into our homes. So that's actually almost exactly identical to the process that happens within a fossil fuel, except the difference is that the heat source in a fossil fuel power plant is coming from the burning of fossil fuels, whereas in a nuclear power plant, the heat source is the radioactive decay of the unstable isotopes of the uranium or plutonium. Okay, and this really just goes to explain exactly what I've just said. So it's worth, and you can see it here in this particular animation. It is identical, but as I said, the difference is in that very, very first stage where we are generating, if you like, the heat that's required to heat up the water and produce the steam. So as you've seen, like with these nuclear power stations and even with the fossil fuel power stations, but more so with the nuclear power stations, is they use up a lot of water. Now, it's true that the water is actually recycled because the steam recondenses, as you can see here, and that is a physical process. It's not a chemical reaction, so we can do that infinitely to keep the water going around the system. Now, the water not only generates the steam, but it also acts to cool the um, the control rods. Now, the control rods are required to control the rate of the radioactive decay, because if that isn't controlled, then you have blowouts where the system reaches critical temperature and causes disasters like we had in Chernobyl. And that's something that, again, you can read up about. Most of you seem quite clued up about it as a result of watching that Netflix program or whatever it was. But that's something that's really required. And so water is used as well as a coolant, which is pumped through the actual radioactive core itself. And so you'll find that many of these nuclear power stations are built on the coast, and that's because obviously they have easy access to water. Okay, and that water is very important for cooling or keeping the temperature at a specific threshold. Okay, if you recall the Fukushima disaster that occurred in Japan, what happened essentially was an earthquake which caused a tsunami. The tsunami then hit the Fukushima power plant, which was on the coast, and that damaged the water pumps, which was pumping the water into the system that took it to the core to keep it cool. And so what happened is that the core overheated and then caused a massive blowout. Now, even though the Fukushima explosion was, I think, a tenth of the intensity of Chernobyl, Fukushima now is still much more radioactive just because it happened uh, um, so much earlier, or no, so much later than Chernobyl. But for us, it's a much more recent event. And so, whilst Chernobyl and the towns around it have mostly been opened up now, Fukushima as a town is still closed off to the general public. There's a very good video by Veritasium. If you type in the most radioactive places on Earth, there's a channel called Veritasium. It's about 11 minutes long. I recommend you watch it. Very, very good stuff on YouTube. Okay. Um, so advantages of nuclear power. Again, reliable generation of electricity, because we know that the reaction is taking place. Most importantly, there's no production of CO2 or SO2. So that massive effect that fossil fuels have on the environment with nuclear power, this is eliminated. Good to meet basic demand. Again, France is a country that generates over 80% of its power from nuclear power stations. So each country has a different policy towards nuclear power. In the UK, I would say we're probably split down the middle. There's much more of awareness and I think an anxiety or cautiousness perhaps to adopting nuclear power just because of the disasters that have taken place. So whilst the disasters are small in number, when they do happen, they tend to be pretty bad environmentally and for people's health as well. So disadvantages: radioactive materials are dangerous. Chernobyl and Fukushima nuclear accidents. Now, it doesn't mean that if you walk past a nuclear power station that is working normally, safely, that you are going to ingest radioactive material. That's not what we're saying. What we're saying here is that if, in case there is a blowout or there's an explosion and the radioactive material from the core makes it to the environment as tiny, tiny atomic particles. That dust can obviously then come into contact with human beings or livestock or plants, soil, whatever, and that way enter our system. And that actually would be a disaster. And in fact, after Chernobyl took place, the radioactive dust cloud traveled through Europe, and if you track where that dust cloud went and settled, the areas that that dust cloud covered in the last 25 years have reported a much higher occurrence of cancer, and that's obviously in line with the dangers of being exposed to radioactive material. Radioactive waste products need to be disposed of after the radioactive material has been depleted. Then it's still actually dangerous, and it remains radioactive. It's just not enough to be used for the generation of power. Then we need to dump it somewhere, and it either gets buried or thrown in designated areas in the sea. It's terrible, and this is exactly what's happening. So that's another reason why people are quite against nuclear power stations. And very expensive to decommission. Again, it's very expensive to decommission because of the complexities with getting rid of the radioactive material and making sure that that's safe. So nuclear versus fossil fuels. Again, this is just a summary of some of the issues here. As you can see with nuclear power, the amount of energy per kilogram of fuel is far higher with nuclear power. And so it's a much more, even though the startup costs of a nuclear power station are much more expensive, it produces much more energy per kilogram, and so it can be argued that there's a shorter payback time, if you like. The waste products, so environmentally, that's going to be a massive difference. Radioactive waste must be stored safely. However, the day-to-day running is not going to produce any emissions. And then it goes on to say here, obviously, no gas emissions as no fuel is burnt, whereas with the traditional fossil fuels, whether that be a power plant or whether that be us burning diesel and petrol in our cars, then we're producing the CO2 and the SO2, and that has a massive effect, as we already discussed. Again, if you have time, whilst this is not on your spec, it can be if they give you the information. And in fact, the third question in your worksheet talks to you about carbon capture and storage, CCS, which is a method that they use in industry to capture the carbon dioxide that is being produced at these big power stations. And in fact, Canada, for example, last year, from all of its fossil fuel power stations, captured 80% of the carbon dioxide that was produced. So it could be argued that if all countries adopted this carbon capture and storage technique, then actually this disadvantage of fossil fuels might dramatically be reduced. So this link here, do click on it. Just to give you, you can just read the very first page, what is CCS, and it just gives you a brief breakdown of the process. This is, again, two very interesting articles worth a read, that this argument of reducing emissions and use of vehicles, we've actually witnessed in the last 3 months globally how reducing vehicles can have a massive impact on the quality of air that we're breathing. And because of this coronavirus pandemic, and as a result, there have been far less vehicles and air traffic has been reduced by 95%, that this has had a huge impact on the amount of emissions, reduction of emission, and as a result, the quality of air. So this is again a very interesting article, worth the read. And then this final article here, by investing in more renewable energy farms, we can actually get to a position where our renewable energy is producing so much more energy than we actually require and then what the consumption is. So this article is talking about the fact that, again, during this coronavirus crisis, as restaurants and factories have shut down, then what that's meant is that our consumption has reduced, and as a result, the national grid is asking for these renewable energy farms to actually shut down temporarily, because what happens is they produce electricity, which is then fed into the grid, and the national grid don't know what to do with it. We can't store this electricity that's generated. It has to be used almost immediately, and if we're producing too much, then the first thing they're going to do is ask these renewable sources of energy, renewable source of energy farms, to actually scale back their activities, so as not to overload the grid. So have a look at that link if you have time. And that's it, really, gentlemen. What I'd ask you to do is now to go complete the worksheet that I've uploaded for you. It's only 3 questions. Obviously, it's broken down into 3 parts, and that hopefully shouldn't take you long at all. Okay, please make sure you submit it to Shobi by Friday, the 5th of June, under the Week 8 folder. And if you've got any questions, send me an email or send a message back to your respective physics teacher on Show My Homework or Shobi, or however it is that you usually contact them. All right, thanks a lot, gents. Hopefully see some of you if and when we go back to school. Take care, all the best. I don't know how to stop doing it. Here we go. Stop sharing. Bye bye.